Hey guys, we're going to look at inequalities in this first video. We'll specifically be looking at the first components here, interval notation, linear inequalities, and compound inequalities. The quadratics and the rational inequalities will be covered in a second video. So let's go ahead and get started. Let's just make sure that everybody's good with interval notation. Remember, interval notation is directly connected toward your graphs of inequalities. So if you have x is less than 4, you would graph it, you have the open bubble, and then it's going to shade to the left. Now, if you will put your variable on the left side, then it's always going to shade the direction that your arrow points. So if you'll literally think of that as an arrow, it tells you which way to go from your bubble. So it points to the left, so you shade to the left. But there's no line underneath, so you leave it open. Now, the interval notation for that is we have negative infinity down here on the left, and then 4 is the end on the right, but since it's not bubbled in, we're going to use parentheses. So remember, if we have these, we have these, that means you're going to use parentheses. If you have less than or equal to, greater than or equal to, you're going to use brackets. And infinity always has parentheses because you cannot contain that endpoint. Okay, so but it's a direct correlation between the graph and your interval notation. So if I can grab that, I'll move him over. And you should see how all of these connect. If you need to do the graph to make more sense out of things, then by all means do your graph. Remember with ands, an and can be written all squished up like this last one. You could split that up. These two are both and problems. Let's get the pen here. Those are both ands. The second one is just squished. You can separate it. This is one problem. Just turn it around where the x is on the left. And then your second problem is right there, x is less than 5. If you wanted to look at the graph, you put the smaller number on the left, larger number on the right. Remember, and implies that both have to be there for it to be a solution. So if you do x is greater than -2, we need that section. X is less than 5, you start at the 5 and then you go to the left. Well, where it doubles up, or you have double coverage, is there in between those two values. So that's the reason our interval is from -2 to 5. Use parentheses because your bubbles are not included. Okay, let's just see here. Let's go ahead and get started. You do need to remember that the big hiccup, or where most people have trouble with inequalities, is the special rule. If you have -2x is greater than 8, and you come through here and you divide by -2, you have to remember to turn your inequality around. So that flips and it gives you -4. Now be careful. Don't think that just because a negative is involved that you turn it around. Because if it was 2x is greater than -8, we're going to divide through by a +2. But dividing by a positive does not make your inequality flip. So this still ends up being -4. But what causes it to turn around is when you divide by a negative. So it all has to do with what is the bottom value. What are you dividing by? Same thing if you had like -x is less than 5. Well, technically you could say you're multiplying or dividing by a negative. Or if you want the shortcut version, change both signs. When you do that, you have to turn your inequality around because you either multiplied or you divided by -1 to get there. The other condition where you would have a similar situation is what we looked at earlier. If you have it turned backwards, we need our x on the left. So when you spin these things, you have to spin the inequality as well. So I suggest that you break it down and do things in just step by step so that you don't get lost. Let's see here. Let's just do like 2 of these. If we're going to do this one and this one, just to make sure we're good, distribute your -5. It works just like an equation would. maintain your inequality. If you need to put the fence up, put it up so that you don't get lost. First order of business was distribute. Then see if there's anything to collect like terms. There's not. You got variable, constant, constant, variable. So the next order of business is to get all of your variables together. I suggest just go ahead and go to the left side. That way you don't have to worry about moving things. Once you get that, then you can move your constants to the other side. And that's going to give me a 10. You're going to, if you'll show the division, you're more likely to remember, oh, I just divided by a negative. So this thing needs to turn around and then reduce your fraction, negative 5/3. Well, if you need interval notation, it depends on how good you are at this, how comfortable. You might want to graph it first. It is open, which means you start at 5/3 and you go to positive infinity because you're going to the arrow. And infinity always has parentheses. That should be good for that one. We could do another one, I reckon. If you distribute this, negative 4x, negative 12, greater than 16. There's no terms to combine, but you're going to move your 12 over. And again, you can show as many steps as you need to or you feel comfortable with. Some of you are going to be able to go much faster than others. But until you get good at flipping your inequality, make sure that you're showing that step. And yes, I have a habit of always circling it. That way, if I get distracted, I still remember that something's up. So this one uses the left arrow, so that's negative infinity. You go up to negative 7, but again, it's parentheses because your bubble is not included. All right, let's move on to what we need to look at is the here we go, compound inequalities. Now, the only one that we're really working with is the AND version. The AND version is when it's all squished together. Now, whenever you have constants on the ends, the easy way to do this is to just solve all 3 sections. Instead of 2 sections of an equation, do 3. So I'm trying to get x by itself. So I need to get rid of this minus 7. So add 7 in each section. So I've got 12. Bring down your less than. You got 3x. Bring down your less than or equal to, and that's going to be 15. Now again, your focus is still here in the middle where you're trying to get x isolated. So I need to divide through by 3, but whatever you do, you have to do it in all 3 sections. So it's going to be 4 less than x is less than or equal to 5. Now, once you get good at this and you get comfortable with them, you're going to know, okay, that just means x is in between 4 and 5. And you can do your 4 and you can do your 5. They're in between and 5 is bubbled. So that means you've got 4 and 5 with a bracket. If that makes you feel totally uncomfortable, you can pull this apart until you get used to it and actually write it out. And here's the other one. X is less than or equal to 5. And you could show, oh, I'm going over this way and this one is going that way. They cover up in the middle. So put as much information in there as you need. By the way, on this over here, all this information, most of the time AND problems are going to shade in the middle. I wouldn't say that the other 10% will be no solution. It's going to be a mixture of no solution and just one direction. And so you might end up with a problem that has these 2 values, but this one's going this way and this one's going this way. So we're just shaded over here on this end. So that is a possible way that an AND could end up shading. All right, so just to do another one, put those in there. You're isolating the x, so get rid of the 1. So you have negative 6 less than or equal to 2x less than 8. Come through, divide 3 by 2. You have negative 3 less than or equal to x less than 4. Okay, if you need the graph, you got negative 3, you got 4. They're in between. The 3 is filled in, so we're bracket negative 3 and 4 parentheses. Now, ANDs can be upgraded. The upgraded version has variables in every section. Okay, this makes this problem much easier, and I shouldn't have done that because we're not even going to work it that way. When you have variables in every section, you have to pull it apart. You don't have a choice. So you cannot solve it all squished up. you have to do the left side and the middle. So I have 3 plus x less than or equal to 3x plus 1. And then I'm going to write the word and then we're going to come back and we're going to grab the middle and the right. So we have 3x plus 1 less than 7x minus 2. Now we just need to solve them both. So there's no terms to collect over here. We're just going to go ahead and force all of your x's to be on the left side. So I got 3 and then a minus 2x less than or equal to 1. Okay, get rid of the 3. So a negative 2x less than or equal to negative 2. You come through there, divide through by negative 2. That means this thing flips. Then come and work the other one. So same thing, we're going to force all the variables to the left. So I got a negative 4x plus 1 less than negative 2. Subtract your 1. So I got negative 3. If I divide through by negative 4, just flip out. Every time you divide through by negative, you got to flip out. So that thing flips, and it's a positive 3/4. Don't let the fraction bother you. You're going to the graph. Which one is smaller? 3/4 is smaller. He goes on the left. 1 is larger. He's on the right. And let's just see how this goes. If it's greater than or equal to 1, he's going this way. Greater than 3/4, that also goes this way. So this is that weird coincidence that we might sometimes run across. Where it doubles is over here. Now that bubble is not filled in. So yes it is. Oh, caught myself. That little line under there travels all the way down there. So yes, that bubble's filled in. That changes things. We're going to start with 1 and it includes that and go to infinity. So even though it's an and problem, you're getting one side of it. Let's see if we can do one more of those just for a little bit of practice, and then y'all are just going to have to practice with your WebAssign. Let me know if you're having trouble with it. Please be careful that you incorporate every term of the middle portion whenever you split. So it has to be from one inequality to the other. All of that has to be inclusive. So I'm just going to do this rather quickly. If I subtract my 1, I get negative x less than negative 4. This is where we change both signs, but that means we multiplied by a negative, so flip out. Okay, subtract your 3x. So I have a negative x minus 3 less than or equal to negative 5. Add my 3. So I got negative x less than or equal to negative 2. Again, I have to change both signs because I need a positive x, so you must flip out again. So go to the graph. 2 is smaller, he's on the left, 4 is larger, and then you're just going to shade like normal. Okay, so greater than 4 is this way, and greater than or equal to 2 is this way. So once again, we're shaded here. Now, notice that this does include the bubble, but that does not affect our answer because that one little dot on the graph is not covered twice. It's covered once. So the only portion covered twice is this part right here after the 4. So our interval starts with 4, and it is a parenthesis because it goes up to the bubble. And then you've got infinity. So that wraps that up. Y'all just need to practice.